Here we go. So good evening and welcome everyone. Really happy that you're joining us this evening and really excited to introduce Rick Snow from Newfoundland and Therese Forsythe from Nova Scotia, who will be leading the session this evening on linear modeling on the TI 8384 environments. So I'm going to push it right over to Rick and Therese. So thanks, Rick and Therese, and thanks everyone.
Okay, Therese, would you like to start?
Sure. I think I recognize all the names from previous sessions, but I'm Therese Forsythe and I teach high school math in Nova Scotia in the Valley. We're going to talk tonight about a little bit about linear modeling on the TI 84, which I do all the time with my students. I'm just going to share my screen. Rick, you can tell me that if it's sharing it.
I will give you the thumbs up for my webcam. I can see your screen, Therese. You are good to go.
So we're actually going to do this by solving a problem. And I actually did this with a group of grade 9s the other day. So I give them real world problems like this one. So in science, Jasmine did an experiment where they collected rainwater in a beaker, measuring the height in half-hour intervals. And so the first thing I would do is I would say, well, is it linear? Do you think it's linear? And some of the students say no, because they know that the delta X has to go up by the same amount and the delta Y has to go up by the same amount. But I said, well, not all data is exactly linear, right? Because grade 9 has a range of students from one end to the other, the nice thing about the TI 84 is it allows you to differentiate depending on the level of students that you're dealing with in small groups. So what I say to them is, because data is not all linear, we work with what's called a correlation coefficient. And I show them this graph. So if it was completely linear, then it would have a correlation of +1 if it's positive, and -1 if it's negative slope. And then we talk about that. So, and then I say, well, what about this graph? Would this be linear? And so they'll say, well, no, it can't be because it goes up and down, right? Which is usually the response I get. And I say, well, no, it's actually not. A cuckoo clock pendulum is actually sinusoidal. So you can have really rich discussions about the different types of linear modeling you can do on the TI, but we're going to focus tonight on just linear modeling. I'm going to go back. So we're going to bring up our 84. I'm going to stop sharing this one. And we'll share this one. So tonight you're going to be in my STEM group. So we're going to actually do regression on our calculator. And one of the first things you have to do is actually turn on your regression, because it doesn't automatically turn on. So are you all ready to go? Do I have thumbs up from people, Rick?
I can see things. Okay, so folks, you may want to open up your handheld, your 84 software, and you can do this along with us as we're going through. So Therese, I think that I'm looking at the chat. I'm not seeing anything in the chat that says that we're not ready, and I'm getting some indication from the chat that we actually are ready, and that we can start doing some. Start putting in some data and turn some features on and see where we go from there.
Okay.
So it looks like we're good. We're getting good
feedback.
And
this is exactly the lesson that I did with my students on Monday. So the nice thing about the TI is that, barring any unforeseen circumstances, once you turn on your regression for your calculator, it stays on. So you don't have to do this step every time you do regression. But so you go second function 0, and I'll leave my keystrokes on at the bottom. And you want to go to diagnostics. So that's x to the -1. And you see, these are all of the functions that are under the D category. So I'm going to scroll down, I think it's 12 times to get to diagnostics on.
Therese, we have one of our audience members, TI 83. In terms of what you're showing here, does this make any difference between the 84 and the 83?
Nope, and I'll tell you when we get to it what changes for the 83. But the diagnostics are still the same. And I only know that, I never used an 83, but I only know that because one of my students had an 83.
So Cindy has a suggestion. She says it might be easier if you use mode and scroll up to diagnostic on.
Yep. Yep. Perfect. It's like I say to my students all the time, the nicest thing about math is there's a lot of ways to get to that finish line. So I'm going to press enter. And in order for you to turn the diagnostics on, you press enter. So once it's done, it's done. It's on. So now we're going to go into our lists in order to enter that data you saw on that first screen in my PowerPoint into our list. So you press stat. And under this window here, you can work with lists by editing them. You can, if you went over to calculate, there's all kinds of calculations you can do, and this is where we're going to do a regression. And then the third category are tests. So when we do probability and statistics, we might do a z-test or a t-test or you know, a sample population. So, but we're going to start with lists in the edit. And I'll put in the data from you. Now it said that Jasmine did an experiment where they collected rainwater measuring every half-hour interval. So we're going to start with 0 and then 0.5 and 1, 1.5. I'm much faster on my smartboard. 2, 2.5, 3, 3.5, and 4. Now, I've already put in the values for the height of the rainwater in millimeters. So 0, 2, 3, 8, 11, 16, 17, 20, 24. So you have to match these.
So folks, I think we're going to wait for a moment here and let you get into the same menu area that Therese is in, and for you to be able to enter in your numbers into list 1 so that you have what Therese has on the screen here, and the same for list 2. And Shannon was wondering if you could type alpha D to get D part of the catalog. Once you pressed second and the number 0 for catalog, Therese, you just pressed the key that was associated with the letter D, and it just came up, correct?
Yeah.
So you necessarily didn't need to press on the alpha key to get the letter D, because in the catalog menu, it assumed that the key that you were pressing on was the alpha key that you were looking for, the letter key that you were looking for, right?
Yeah, because when you press second function 0, the alpha key is on right here. Can you see my cursor move around?
I can, yeah. I'm seeing you move it around there, yeah.
So that alpha key is already turned on. So whatever letter you press, in my smart view, it's the green letters. Whatever letter you press, it'll automatically go to the functions in the catalog that start with that letter.
Good, excellent. Okay. So let's bring up your list again now, Therese, and just make sure that we're able to say, no, that was good, thanks. The question was in the chat, so it's good to answer that. So,
nope,
so folks, you enter your data into list 1 and to list number 2, and as soon as you have that done, just feel free to let us know in the chat that you are good. Now, Crystal has a number entered in by incorrectly. Therese, can you show Crystal how to get rid of a number that perhaps is incorrect?
Yep, you just go like this. So I'm on here, and I want to go to the end, actually. You go here, and you press delete, and it goes away. You can also overwrite them. So say I put...
Yeah, it won't delete for me on my, it won't delete or clear. It's weird.
So if I said I put 4.5, I don't want 4.5.
Yeah.
If I go back up and press 4, it'll override it.
Yeah, it won't. That's weird.
It is weird.
Yeah, okay. No worries, I will figure it out.
Are you using the software or a handheld?
Yeah, I'm using the software. Like, it's never an issue on my calculator. It's the first time I've had the software up. It doesn't want to let me.
Okay.
Can you go back? Oh, sorry.
That's okay. I'll just play around here for a minute.
And maybe go back out and go back in,
Yeah.
just to refresh it.
Yep. I think it's okay now. I think it was just frozen.
Yeah,
Okay.
Crystal,
Thank
that
you.
happens sometimes. I mean,
Yep.
you know, like any other applications on our computer, every now and again it gets, you know, no matter how good or bad software is, sometimes things can get a little sluggish. So that's not unusual for that to temporarily freeze like that anyway. I
Okay,
mean,
thank
that
you.
happens before, yeah, as an example.
one thing I'm gonna point out here, because some of my students had this, both of my lists have 9 values in them. And so some students, when we were doing this activity, they said, I get this screen that says dimension mismatch. And what that always means is that you have 9 values in list 1, but you might have 10 in list 2. So these two have to match in order to do the linear modeling. Match in the number of numbers in there.
Yeah. So if we're making a Therese, if I'm understanding you correctly, if we're trying to make an association between the dependent variable or the dependent list and the independent variable or the independent list, they have to have the same amount of data for it to be able to do things correctly. Yeah. Okay.
Yeah. So the next thing I do is I say, well, we have to turn on a stat plot, right? Because we're going to make a scatter plot. And so I tell them to go second function y is equal to, and right now all of mine are off. So I just press enter and turn it on. And you can see all the different plots that we can do. And if I was doing 4 or 5 stat plots, I could change this L1 and L2, and I can also change the color.
Yeah. And Derek makes a good point too.
You're right, Derek.
Therese.
Yeah.
Yeah.
That's exactly what happens.
Yeah.
Yeah.
And that's how we get the dimension mismatch. Yep.
Yeah.
Thanks, Derek.
And then the next thing I tell them that we have to do is we have to change the window, because every linear modeling problem that we do does not have the same window. So I can't remember what I was working on. Oh, I was working on another problem today. But if I look at my list, I tell them to give me the minimum and maximum value for X and the minimum and maximum value for Y. And that's what we're going to do in the window. So we're going from 0 to 4. I always like to see the 0, 0 mark if I can, like on the coordinate grid. So I always leave it at -1. And then I go up a little bit higher than the maximum Y. And I change my scale. And then my maximum Y value was 24. I'll make it 25. And I'm just going to go up by 2. So are we okay with the window? Anything?
So folks, let us know if you've been able to successfully adjust your window to be similar to what Therese has here. Just let us know in the chat, and that way we're okay to continue to move forward. The other interesting thing too, you know, while Therese leaves this up here, is that you can press on the zoom key, and there's an option there to zoom according to your list, and it's zoom stat. But it's also interesting. Oh, sorry, Tom, go ahead.
Yeah, Shannon shared it in the chat actually. Zoom 9, I'm assuming, is Zoom stat. Is that right, Shannon?
Yeah.
And what's interesting about that, that's fine if you're doing things, you know, with the 84 quickly, if you just want to see a quick view of the graph. But what Therese is looking at here, you know, by changing the window, we're looking at the maximum and minimum for the domain, and we're looking at maximum minimum for range. So, you know, being able to fit data into a window and to be able to associate that allows you to have a little bit more conversation about the data.
That's right.
And it's a little more thinking too, rather than sometimes Zoom 9 takes that away, that looking at kind of what does it look like, the data kind of thing, and think about the data. So I kind of like doing the window reasoning, thinking back to what is in the data. Yeah.
That's right. And I connect that window right to whatever problem we're doing. So that they look at the domain and range.
And in some curriculum that I've seen, and I know that our curriculum in Newfoundland would have some of this on times, it's being able to take a data set and then be able to make it fit appropriately on a graph, as opposed to having, you know, an 8.5 by 11 sheet and then having a centimeter by centimeter graph in the bottom. The whole idea of being able to do that and knowing how to do that, both pencil, paper, and what we're doing here on the handout certainly translates to that as well, right?
Yeah. Okay, are we ready to graph our data?
But folks, are we all good with regards to the window changes here? Just let us know in the chat.
Yeah.
And we can continue to move forward.
Okay.
Yeah.
So
That's
we're
okay,
gonna
Therese.
calculate the equation for the line of best fit. Then we're going to plot that on top of our scatter plot. And so we press stat. Remember I said the second category allows us to do calculations. And we look down and I had asked them if they thought it was linear. So I'll say, well, which one's linear regression? And so they always choose 4. I think because we do y equals mx plus b, and they don't recognize this as easily as they do 4. And so I say, well, did we put our x's in L1? Yep. Y's in L2? Yep. We kind of ignore the frequency list right now, but then we're going to store our equation into Y1. So I'm going to press VARS, which is right here under the distribution key, Y VARS, and I'm going to put it in the function of Y1. And then I say, well, let's calculate it. Let's see what it is. So we calculate it and we get y equals 6.2x minus 1.18 with a correlation coefficient of 0.9923. Now I do for some of them go into the difference between the correlation coefficient and the correlation of determination, which I did put on the handout that Tom is going to give you at the end. But the people that I said, well, they're not sure if it's linear, then I say, well, 0.9923, does that represent a good correlation, a good positive correlation? So that gives them proof that it is. So then we press graph. We've already set up our window, we've already turned on our stat plot. So we press graph, and we see that the dots or our squares are closely matched to that linear equation. And we also, for some of them, I talked to them about calculating residual values, which we don't have to do anymore in math, but it's a lot of fun statistics. But so anyway, so that kind of proves that our 0.9923 isn't a perfect correlation, and they can see why it's not a perfect correlation.
But you could, it'd be really easy to do some if you wanted to see the distance of each point vertically to the line, like in your list, it's so easy to do now, right?
Yeah. And we get into some of that stuff later on.
Yeah.
But we just started correlation Monday.
Yeah. So folks, were you able to successfully get your line of best fit to draw on your graph? Let us know in the chat if you were able to successfully complete that. And if you need us to go back over the steps, let us know that as well.
And just a note too, obviously, if kids are using the TI-83, there's not going to be color, right? So the color is for the new 84 plus CE, right?
Yeah.
Or for the software. So Maria got the scatter plot, but not the line of best fit.
So the line of best fit, are you using an 83 or an 84, Maria? An 84. Okay, so when I go to stat, I'm just going to close my chat because I can't see my screen, and calculate, and 4. Remember we said we did put an L1, L2. This store the regression equation, that's where you're going to put your line of best fit, where you're going to put the equation that you get, the y equals 6.2 x minus 1.18, into y1. So you press vars here, and then go over to y vars, because it's going to put the function in the y is equal to column, this column up here. And then I press 1 for the function, and I'm going to put it in y1. So this gives you your line of best fit. And then when I press calculate, and I'm just going to show you my y1, here's my equation, and then here's my y1. So it has, when these two are both on, you'll get both equations when you graph the function.
Did that work for you, Maria? And just a little note kind of on the dynamics of doing a webinar. and using the software versus a handheld. There's something sweet about using a handheld because you're not toggling back and forth between screens of, you know, this and that. You can just have your zoom up kind of, and then be doing stuff on the handheld. Awesome, it works now, beautiful.
But it's really great, and for students that haven't done this before, they're just, there's oohs and ahs as soon as they get the two
So
joints.
Philip is asking, Therese, how are you getting your data points to show on your graph? So I think he's asking about the scatter plot.
Yep. So if you go second function y is equal to, you get your stat plots. And all of mine were turned off, but I went into the first one and I turned it on. So right before I went in, it looked like this. So on was clear. And so I just toggled over to on and pressed enter. And then it turned on. Does that answer your question, Phil?
Perfect. Yep.
Okay. All right, that's my part of it, Rick. And I'm going to stop sharing. If anybody
Do you
has
want me to
Stop
push
sharing.
the handout at the end of this, the very end of the session, Therese, or
you may as
now?
well, because
Okay.
Phil Rick is going to do something else using a different piece of technology with the
Perfect.
TI.
Yeah,
Yeah.
Therese, we got a little bit of time, so if you don't mind, can you go back and share your screen again?
Sure.
And we'll just quickly talk about the tracing of the data points in the scatter plot versus tracing the line of best fit, because that might be important for us as we go in and we talk about data and we talk about that analysis with students.
Rick,
So
it's Derek. Can I just ask one thing?
Go ahead, Derek.
Because this may have happened to other people because we're running programs. The programs that you may have run in the past might have turned off your axes just because it's using the draw screen. So maybe we can just talk about F3, the format, and maybe if anyone else has, because that was my issue. So I had to go into the format F3 and actually turn the axes on.
For F3, format, yeah. Yeah, so you can go in and turn on. You can also change the color. One of my students had a picture on his of a bridge, and so I showed them how to go in here and turn on the axes and turn your background color, and if they wanted a grid. So if you just press second function zoom, you get this screen here that allows you to turn on your axes.
And Therese, I think Stephanie made a point about the different kind of marks on a scatter plot before
Yep.
we go to the trace.
That's right. So if I have a lot of points on mine, like I did the little squares, but I was doing one that had like a lot of points. So I made them smaller so they weren't taking up so much of the screen and they weren't a priority. More the line of best fit was a priority.
Yeah.
Yeah. So you can change those whatever way you want.
Yeah. So I think, Stephanie, your point, and feel free to open up the mic and chime in here. I think your point is that if we used a really small dot and we had a really good line of best fit, we may not actually see much of our scatter plot, right? Whereas the bigger mark allows you to really see the scatter plot and the line of best fit simultaneously.
Yeah. It only becomes cumbersome when you have a lot of data points.
Yeah.
Right.
Yeah. So Therese, before you finish sharing and I take and I present my screen, how about we show the trace feature for the graph? So you notice, folks, by pressing trace, we trace along the scatter plot there, so we can jump through the different data points in the scatter plot. And that's good in terms of conversation. Look at data points that are above and below, and the ones that are really close to the line to talk about, the comparison with that correlation coefficient and how close those data points are to that line of best fit. And then if we press on the up arrow, we should be able to switch from the plot and go into the line of best fit and just use a continuous trace here and to trace along the lines of best fit.
And it's really interesting too, because when we talk about, like if something was considered an outlier in this particular graph, what would you consider those? So they would quickly be able to see that there's a huge discrepancy between, say, this point and then the other point. Oh, sorry. And then the blue point. So yeah, so there's a lot of great rich discussions you can have with students about both the graphs that they produce.
Excellent. Excellent. Therese, is
Okay.
there anything else you'd like to add before you stop sharing again?
I don't think so. I'm good.
I'm going to jump in for a second here, because I realize what a neat opportunity we have, kind of with the makeup of the folks, both the presenters and the participants this evening. So we've got so many different parts of the country, so many different curricula, so many different experiences represented here. And it's really interesting. Linear modeling obviously kind of cuts across all those geographic boundaries. But one of the things that we're engaged with here in Ontario is implementing our new grade 9 streamed curriculum, the MTH1W. And one of the things that I find kind of interesting, that I'm hoping that Rick and Therese will kind of lean into a little bit, and the rest of you folks on the session too, is that the rest of the country has been de-streamed in grade 9 for a long time. So you have a lot of, you have a lot of wisdom to share with us in Ontario in how you've approached things, made learning accessible for everyone in grade 9. So again, I'm not sure if people on the call are aware of that, the Ontario folks kind of that are on this evening. But we do have kind of a rich opportunity here to dip into the experiences of folks in the East, the West. Actually, pick any province other than Ontario, and grade 9's de-streamed. So
all of our curriculum in Nova Scotia is de-streamed for grade 9. We don't start streaming, although they don't allow you to use that word in Nova Scotia, until grade 10. So in grade 9, we have everything from what we call an IPP, or a personalized program. So a student might be at the grade 2 level math, that we write specific lesson plans for that student. And then I have a student that I'm doing a little bit of calculus with. So, and you have everybody in between and I have 32 kids in every class. So you get really, really adept at creating differentiated instruction for the students. The nice thing that we did this year is we actually have, with Tom's help, we're doing a STEM group every Tuesday and every Thursday. So we take the students that will eventually go into the International Baccalaureate program, and we do a little bit higher level math with them, just them. And anybody can join, but it's geared to the students that are going on to the programs like pre-IB math and math and the IB program. To have de-streamed in grade 10, I think would be really scary, because grade 10 is in Nova Scotia. Grade 10 is where the marks count, right? So up until grade 9, you get a pass no matter what. You can't fail a course from P to 9. I don't know if it's the same in Newfoundland, Rick, but
yeah.
But in grade 10 they can. So in grade 10, like my grade 10 pre-IBs, they actually get 2.5 academic credits for it, but the marks count.
And Stephanie, out in Alberta, it's de-streamed in grade 9 but streamed in grade 10. Is that correct, Stephanie and Victoria?
Yeah, that is correct, Tom.
Yeah.
We don't have streaming in grade 9. And in grade 10, we used to have 3 levels of math, but now we have something that's called Math 10 combined for different routes. And then we have one that's a 10-3. So we have had de-streaming in grade 9 for forever.
Yeah. And folks, for those of you that perhaps are not aware of what happens in other parts of the country, basically, the Western curriculum, the WMCP, the protocol, for the Western provinces. Often in the Atlantic part of the country, we often kind of piggyback or adopt curriculum from other areas. And in Newfoundland and Labrador, for example, our curriculum very closely mirrors at the intermediate high school level for mathematics the framework from the Western provinces. So, and as a result of that, we're able to tap into the publisher resources and things like that. And what Stephanie just mentioned to you in terms of a combined 10, that also happens in our province as well. And actually, we don't really stream, if you're going to call it streaming, and separate the advanced from the academic from the non-academic or the slightly lower level courses until grade 11. But our grade 9 is one stream. And what's interesting, and you're looking at the technology application, and you really think about your curriculum outcomes and what your curriculum outcomes are what the expectations are for those students. And sometimes we get caught up into some things that perhaps some of our weaker mathematics students are not as good at in terms of some of that basic computation, but the higher order thinking is certainly there. So you really got to look at your D stream 9. You really got to look at your curriculum outcomes and say, what is the expectation here? If the expectation is, to factor, for example, and not necessarily know multiplication tables, then you might want to slip a little bit of technology in there to help with that, so that your students are able to have success regardless of where they might be in terms of the academic level. And that's kind of when I taught in grade 9, that's kind of and intermediate in general, that was kind of my approach, was that the technology might help us out here if we use it in the right way and we use it responsibly.
And to add to that, Rick, that difference in ability can change from topic to topic, right? So I always have what I call high cognitive demand parts of the day, and so different students will attend those high cognitive demand activities with me, depending on their comfort level with the material. But it's always the same group, and then we have a few extra, and then some of that group might not say, I'm not, this is as hard as I can go. And so and then the technology allows for that for you, which is what I really like. And Tom knows I have a calculator with me at all times. But I love the technology, and I use it all the time in my classroom.
Yeah, and for me, it was the same way when I taught in the classroom. In a D-stream intermediate classroom, there was no question. I mean, the technology, I made available to students as needed. The technology was the tool in my classroom, and as the students needed it, or if they didn't need it, that's how I provided it. So
yeah.
Which is a beautiful segue to the stuff you're going to do now, Rick.
Yeah,
Yes.
I'm gonna share my screen, folks, and let me know as soon as you're able to see my screen, because I'm just gonna connect my motion and to bring something up on the screen to make sure that we're good. So let me know, folks, as soon as you are able to see what I've got on my screen here. Now, I'm just going to make sure that I see the chat and the participants as well as I'm going through. You guys should be able to see this little piece of technology here.
Yep.
And I will tell you, this little technology here is a motion detector. The easy way to describe it is a motion detector. And I started using this with students from grade 6 when I taught in a really small school, all the way up to level 3. I use this for a whole bunch of things. And I'm going to show you one example of how I use it tonight. But this technology was absolutely integral in my classroom when I first started. And just to give you a perspective, I'm going to use software tonight. I'm broadcasting it via Zoom. When I first used this technology in my mathematics classroom, I had an overhead projector. I would connect the CBR into my graphing calculator, and I would plug my student graphing calculator into a panel that I would project with the overhead projector onto my chalkboard so we could do some analysis. So I've been using this technology with students for a very, very long time. And
if they had chalkboards.
back when we had chalkboards, yeah. And to me, if I were back in the classroom now and I wanted to teach anything about interpreting graphs, this would be my go-to tool right now. So without any further ado, I think that I will lower down the website that has the CBR, and I'm going to start. So Tom has a handout that he'll provide at the end of this, of the screen captures that kind of lead you through what I'm going to do here. Okay, but I just want you to watch, follow along. Let's have a conversation about what we're seeing here for the next 25 minutes or so. Feel free to type into the chat. Tom and Therese are keeping an eye on the chat for me as I start using this. So let's go. I'm going to click on the apps key, and I'm going to go down to number 5, which is easy data. So when I select number 5 and go easy data, I get this screen that tells me that, yeah, everything's connected. We are just about ready to go. And if you notice on the screen that as I move, and maybe I can tip down my screen a little bit, as I move my hand back and forth, you can see that it's picking up the motion. Okay, so you can see that it's picking up the motion away, picking up the motion close. And if I were to stand further away from the motion detector, walk towards, you'll see the distance change. So it's calculating the distance between myself and that CBR2. And that's what you're seeing metered or displayed here. But we're going to do, since the theme of our session is linear modeling, we're going to go into our setup. So our things here, our different tabs here are actually the keys up above. So I'm going to click on the window key for setup. Now, this activity that I'm going to show you now is a distance match activity. So we're going to actually draw what we're going to see on the screen. We're going to try to match it using the motion in front of the detector. Okay. And in case you're wondering how I use this, I taught in a really small school in Northern Labrador. And I was a teacher for intermediate and high school. What I would do is that when it came time to combine classes for common curricular outcomes, if I had in grade 6 that students had to learn how to interpret a graph, and in grade 10 they had to learn about rate of change, I would bring all of those students together into one room, and I would set up the motion detector. And with that motion detector, I would mark off meters on my floor. I would project this, and I'd say, okay, see that graph? Make that graph with that motion detector. And I would not tell them how it worked, other than the fact that motion changed something on the graph. And I would let them discover the different components of graphs when we graph distance time. So number 3, distance match. Okay. So I can see that it's picking things up. I am ready to start. Now, what it does, what the application does is that it creates different types of graphs that we're going to try to match. And we're going to try to match it with movement in front of the motion detector. So this is where I'm going to need you in the chat to tell me what it is that I need to do to make the graph that you're going to see. I'll press next, and here's our graph. Now, when you look at the different parts of the graph here, can you tell me what I would need to do in front of the motion detector to make that graph? And feel free to type your answers into the chat. What would we need to do to make that graph? Sammy's got some suggestions. So I have to stand at least 2.5 meters away from the motion detector. Maria's saying that I got to walk towards the motion detector for about 1.5 seconds. Yep. Anything else? Shannon's saying walk towards the detector. Okay. Yep. Anything else? Are there different components of that graph that we should consider?
Maria saying constant speed. Yeah. And then Sammy's interpreting, so stand still for 2 seconds. Jemima's saying stop between 1.5 and 3 seconds.
Yep. And then what? What else do we do after that?
Move faster.
Move faster. All right. So I've got my wireless mouse here, so I'm going to be able to stand. I think somebody suggested about 2.5 meters away. So let me see if I can get about 2.5 meters away. And you'll notice that one of the things that might be hard to do is to talk about distance away from the motion detector and distance towards. You can see by look of the fact that we are using webcam technology here, you can see me moving away and moving towards. So what you're going to see on the graph, you're going to see my movement in the webcam associated with that. So I'm going to press start, and let's see if I get this right. I didn't do a very good dancing, did I? What did I do wrong? What did I do wrong? Any suggestions?
So when kids, what's beautiful about this, when kids do it, they'll always ask, "Oh, can I do it again?" So right
Right.
away they have ideas of how they want to improve it, right?
Yeah. Yeah.
So
So,
Cindy says you went the wrong way after the pause.
yeah.
You moved away back instead of forward.
Yeah.
Yeah, you walked away from the after pausing.
Anything else that I did incorrectly how did I start? How did I start? These are all good questions. These are good probing questions. Now, we haven't talked about slopes and rate of change and initial placements and things like that. We haven't talked about, horizontal slopes or zeros. We haven't engaged in any of that conversation yet.
So Cindy wants you
we're
to
talking
be
about,
further away when you start.
right. So I'm going to see if I can retry this. So let's see if I go back to here. And you have to understand, I'm in my room downstairs, so the amount of distance that I have to move is a little bit compromised. But let's select retry, and let's start again. What are your thoughts? Bit better? How would you feel about that? Need a bigger room, Cindy. Exactly. Might need a bigger room. That's very true. So I'm still not far enough away. Now, if I were in a classroom, and when I did this in the classroom, the first thing I would do is I would tell the kids, push everything off to the side. Let's get everything out of the way. Because the motion detector picks up motion in a conical shape. It's a conical shape by which it starts picking things up. So the further you are away, the further out it's looking for that motion. So we want to make sure that our view is unobstructed. I'm actually using my stand-up desk tonight to make sure that the motion detector is far enough up so that it doesn't pick up the other things that are in the room here, right? And I agree, Sammy is better than before. How about we try another one? So I'm going to select new, which is the window key here, and try this one, see what happens. Now, what do we have to do to make this graph? Suggestions from anybody in the chat?
Everybody's thinking, Rick.
Everybody's thinking, and this is exactly what would happen in my class. The kids would stop and they'd look at the tape and they would think about the distance from the motion detector and they would think about, okay, the last time I made a mistake, the graph went one way and I went the other. The data went the other. What caused that? And these are the kind of these are the rich mathematical conversations that you want to have with your students. Okay? And so Crystal's got some suggestion in here. We're going to start at about 1.5 meters away. Then we're going to move back at a faster pace, and then right away move towards the CBR. So I'm going to try about 1.5 meters away. I think I'm about ready to start. Let's see how this goes. And again, distance in the room is an issue.
And there's a word that Crystal used in the chat that's really important. A few people have put it on here. This idea of constant speed is really important. Obviously, if we're dealing with linear modeling here, right? So that idea of constant speed or constant rate of change, yeah.
Yeah. All right, let's try one more, and then we'll continue on. So we'll do one more model. We'll try this one. So what do we have to do to make this graph? What do we have to do to make this graph? So again, I have not said a single thing about how we should be doing things. I have not disseminated the information on the mathematics here. We're trying things. We're talking about things. We're engaged in a conversation. Okay. So we got some suggestions there. Walk away, then slowly at 1.5. Yep. Yep. Let's see if I'm close to the motion detector and I press start. Okay. Let's retry that one more time. Okay. So we're able to get closer and closer to the model. We understand the concept of the initial place that we should be. We understand the whole idea of walking away, walking towards, and so on.
But
So,
Sammy says your speed wasn't constant in the middle. It's an interesting thing, the biomechanics of it, right? So when you're going slow and you're trying to go at a constant pace, our body doesn't move because of our one foot and then the next foot. Like
yeah.
our body isn't necessarily moving forward at a constant pace. So that's an interesting thing. And then the other cool thing about the messiness of this, Derek says that he likes the rounded parts of your curves at the bends between motion toward then away, instead of the kink and the sharp end, that you can't change change direction instantaneously, that there has to be a deceleration and then an acceleration in a different way. Yeah.
Yeah, there's a lot of conversations to have here. We can easily tie this into some of the early high school physics curriculum and science curriculum. I mean, there's lots of extensions here. But for me, when I taught this in my school, I brought it in from grade 6 all the way to grade 10. And
Maria is saying try it with a remote control car. Actually,
yeah,
Maria, there's a the TI Rover, the little blue robotic car. It actually has, it looks like headlights, but they're actually motion sensors, sonic sensors in the front of them. So you can do that. And Sammy said, or with a mini drone. Yeah, there's actually cool stuff you can do with that too. Absolutely.
when we used to have curriculum days, like fun curriculum days in our school, we would always set up the motion detector, and we'd ask the kids from the primary elementary grades, because it was a K to 12 school. We would ask them to bring in the remote control toys, and what we would do is that we would have a contest to see which toy was the fastest. Now, the job of the intermediate high school students was to run this for me, and they would have to calculate the speeds using the data that was collected to determine which toy was the fastest. So there's a bit of a fun there, but some curriculum as we were doing things that were fun as well. So,
and what's really important too, kind of in the whole de-stream kind of conversation we were having, like this is just accessible to everyone. It doesn't matter who's in the room. They're like someone at the very beginning says this is so engaging kind of thing, but it's accessible to everyone. And it's not, you're not starting with algebra, you're not starting with calculations, you're not starting with, all kinds, you're just moving. and you're watching your motion in real time be represented graphically, and all kinds of cool stuff starts to kind of happen in everyone's mind. So I think in our Ontario grade 9D streamed context right now, this is a really powerful tool that needs to be part of kids' experiences for sure.
Yeah. And think about it from an assessment perspective as well. Let's say that we do have students in our classes that perhaps are not the greatest test takers in the world. And we've all had them, and we all know we probably got them now. Could we sit down and talk about these things with a student and still be able to assess the outcome that's being measured without necessarily having to do a test? I think we might be able to. And we might be able to say with confidence that the students have learned. Yeah. Now, we're going to do a little bit of analysis because we were talking about linear modeling and things like that. So if you can see my screen, I want to be able to grab this part of the data and do some analysis on that data. Okay, so I'm going to grab this piece here. So I'm going to use my keys here. I'm going to press on the trace key to go back to the main menu. And I'm going to go to where it says graph. And that's what my data looks like. Okay, that's what my data looks like when I collected it. And chances are there's a little dip here that probably happened because I stepped away a little bit out of the range of the motion detector, and it could have picked up something else in the room. Anything's possible. And as Derek mentioned, I think if I could work and create those sharp curves, I don't think I'd be a person. I think I'd be something else altogether. So the curves are there as well. So I'm going to grab this little piece here and we'll do some analysis on it. So in the middle here, we've got this analyze feature. So I want to go down to number 7. I want to just select a piece of what we drew here. So I'll go to number 7 and select region. And I'm going to delete out all the other noise, all the other data. I'll press OK. Now, I'm going to go to the left bound and probably pick the data up to about here. Press OK. And then from the right side, I'm going to come back and I'm going to grab the other piece. And I'll use that for the right bound and I'll press OK. So there's my data as a handy dandy scatter plot. Now, if I'm talking about what data we have here, perhaps this is data that's linear. Back to Therese's activity earlier on this evening. So I might go back into the Analyze menu again and try to see if there's a linear fit for this data and just how good that linear fit is. So number 2 for linear fit. And I've got a value of A to be 0.49. And I got a value of B to be 0.377. So what does that mean? What does that mean? If I press OK and graph that, what do those values of A and B mean? And that will be good conversations as we're starting to take this from what we're talking about in the description and the moving and start applying the mathematics of slope and related that to rate of change, the y-intercept and initial value. This is where we can start having these conversations now because we're looking at the data and we're doing our analysis that way. So I think we're done with the data in this format. So I'm going to go back to the main menu, press graph, and I'm going to go to quit. And as Therese had mentioned in the activity earlier on this evening, her data was in list 1 and in list number 2. The data from this activity, because I selected the region, is in list 1 and list number 6. So if I press OK, I'm done. Now, if I press on the stat key and I go to number 1, which is edit, I can see the data in list 1 and the data is in list 6. So I still have the data. And I can actually graph that data outside of the DataQuest application. Now, where's my line of best fit? Therese's from earlier on this evening was in, she was able to turn it on using the Y equals key. Correct, Therese? From the application here, so is the line of best fit that we determined from the region. All I need to do is to move over to the left where the equal sign is at and press enter to turn it on. And then when I press graph, I have my graph here as well. Okay, so what you're seeing in Therese's activity, we can do the same kind of thing here. Now, the last thing is to talk about independent and dependent values based on that line of best fit. What kind of things might we want to know? We might want to know where the initial value was. We might want to know the distance after, after 2 seconds. We might want to know the distance after 4 seconds, for example. How can we determine that from here? Well, as Therese showed earlier on, we can use the trace feature. But there's another feature on the 8384 that you can also use. And it involves using the table, which is above the graph, using the second key and the graph key to bring up a table. But I want to be able to ask the handheld to give me the values. So above the window key is this table set option. So I'm going to press on the second key and the window key. I'm going to start the table. I'm going to actually start it at about -3. And I'll go up in increments of 1. Now, I want to be able to input the independent value. So I'm going to change the table so it asks me for the independent value. And then after I do that, I want to be able to prompt it so that it asks me for the dependent value, and then I can check the answer. So I'm going to select ask for both of those table sets. Now, when I look at the graph, I'm okay. When I press on the second key and the table key, I've got an empty table. Now, before we go any further, can you remember what the y-intercept was for my line of best fit? Does anybody remember? When I put in a value of 0 and press enter.
We have 0.49 and 0.45 kind of
Okay, so
ideas.
Let's go over. So if I want to find out what the initial value was, I enter the value of 0. And when I press enter, that tells me what the initial value was. Now I can move over and enter, well, at 2 seconds. What was the value at 2 seconds? That was the distance at 2 seconds. At 4 seconds, what am I looking at? Move over and up. And that's what we have.
So Rick, if you had put in a value of 3 for 2.35, would it automatically change it for you?
Well, let's go back and look at it again. I'm going to put in 0 again. And this time, if I put in 3 and press enter, it's still going to kick me out the answer that it's got stored. Yeah, still going to kick out the answer I've got stored. So you see, I'm not necessarily, we're asking for the values. This can be a good check when we're looking at linear functions and things like that. And that is everything that's in the handout that Tom will share with all of you later on. And
can you also can you go down and put a value in for y1 and ask it to return a value for x?
Well, let's try it. If I put in 6 there, I'm not going to get anything. It depends on the dependent value.
Gotcha.
So let's change the table set, and we'll have the independent value to be automatic and the dependent value to ask. And now when I go to the table, it's going to give me the independent values, but I have to move over and it'll provide the associated y values. So that's how that works. If we change it from independent or from auto to ask and back and forth.
And it works the other way too.
And it works the other way too.
Yeah.
So folks, we're close to the top of our hour. Any thoughts, feelings, opinions, questions, comments, concerns before we wrap up for this evening?
I just popped in the 2 files. So the screen capture guide is the handout from Rick, and the linear modeling TID4 document is from Therese. It's in the chat right now, so you should be able to do that. Paul is saying the transform map is also a great way to use sliders to fit functions to data.
Absolutely. So let me just press graph for a second and press Y equals and turn that off. And under apps,
We can't see your screen, Rick.
oh, sorry, I've stopped share. Hold on, real quick. And folks, here we go. Paul's referring to this transform app, and we press enter. We go to Y equals. Now we get to be able to do some things inside of here. Yeah.
Is everyone seeing the handouts? Some people were saying they didn't see the handouts posted in the chat. Can everyone see them?
I can see them, Tom.
Okay, perfect.
Yeah.
Perfect. So just to close out, since we're kind of on the hour right now, huge thank you to Rick and Therese and to all the participants for your active participation. I just wanted to share something around and next week, and also just to make sure everyone is aware of. I'm so used to not presenting anymore. Like, what's how do you do that again? Where is it? I'm looking for the share screen thing and I can't find it here.
If you go down to the bottom, it should pop up, Tom.
There it is. Yeah. It's been so long. I've just been watching other people kind of share screen here. There we go. So if you go to the stemsupport.ca website, you guys are all aware kind of the webinars has everything posted. So tomorrow morning, the recording for this session will be here along with the files. And all the historical archive of all our sessions are posted here for you. I did want to point out the newer parts of the Ontario math curriculum, the MTH1W. Financial literacy is part of it. And Anthony, who's actually doing a session for teams this evening, and Paul are going to do a session on financial literacy with the TI-83, 84 environments. And if you click on this link, it actually takes you to a bunch of supports, or if you go to curriculum supports, Ontario MTH1W supports, there's a bunch of really nice things here. And next week's session is kind of focused on this. So if you clicked on financial literacy, you'll find all kinds of interesting things here. So they'll reference these next week. And the other thing too that's useful for specifically Ontario teachers, but also kind of for the other people in the rest of the country, this is a curriculum alignment document for people that are using 8384 handhelds. So I can go over here, here's an expectation, I click on this, it takes you to an associated activity that's related to this. And we also have a curriculum alignment document for the TI Inspire. And if you go to education.ti.com/Canada, maybe someone can, I'll throw that in the chat here, or maybe one of you guys can. And if you go to resources, for the folks in the rest of the country, if you go to get the curriculum alignment documents, and I'm just going to arbitrarily say Saskatchewan, or yeah, let's say Alberta, and it takes you to a page where you've got documents that are aligned to the different courses for the different technologies. So if you wanted to take a look at the Grade 10 Common for the TI Inspire, it downloads a zip file, or if you wanted to do it for the 84, same thing. It just, so please know that there's lots of support for people all across the country here. And I'm excited that we're getting these sessions led by people from different parts of the country, because they bring their different perspectives, their different experiences, their different curricula to the table, which I think is really, really rich. The STEM support, Cindy, is just stemsupports.ca. It's where you probably registered for this. Oops. Thanks, Paul. So yeah, those are two good reference points, stemsupports.ca. and then the education.ti.com/Canada. And if you need to reach out to me, let's say you've only got 1 or 2 CBR2s and you wanted to do something with the motion sensors, like Rick was doing, contact me. We've got workshop loan stuff. Let's say you've only got a couple of TI-84s and you want to do a linear program or a linear modeling activity like Therese did. Well, we've got workshop loan kits for the TI-84 that we can send out to you to use either with your students or teachers. So know that we're here to support you for whatever you guys need. So thank you very, very much, Therese and Rick. Thank you all for joining us this evening. And we're looking forward to seeing you guys next week for our last in our fall series of webinars on next Wednesday with on financial literacy. So thanks. I'm going to stop the recording now.